4. We're so glad to see so many of you lovely people here tonight. We would especially like to welcome all the representatives of Illinois' law enforcement community who have chosen to join us here in the Palace Hotel Ballroom at this time. We certainly hope you all enjoy the show. And remember, people, that no matter who you are and what you do to live, thrive, and survive, there's still some things that make us all the same. You, me, them, everybody. Everybody.
Everybody needs somebody. Everybody needs somebody to love. Someone to love. Someone to love. Sweetheart to miss. Sweetheart to miss. Sugar to kiss. Sugar to kiss. I need you. I need you. I need you. In the morning, when my soul's on fire. Sometimes I feel a little sad inside. When the man on the streets man.
All right, hi there. Today I'm going to be looking at chapter 4-1 of Algebra 2, quadratic functions and transformations. So I'm going to start off with this problem right here. Fill in the table and graph the points. And this is the equation right here, y equals x squared plus 1. And so I'm going to plug the values for the x in here, and this is the first way usually you learn how to graph. So when I take 3, for example, and I plug it in here, you get 3 squared, which of course is 9, and 9 plus 1 will give you 10. If I was to change that and plug in the 2, this will equal y, so that's why I'm filling in the y column. 2 squared is 4, 4 plus 1 is 5. If I changed it and plugged in a 1, 1 squared is 1, and 1 plus 1 is 2. If I plug in 0, that would be 0 squared plus 1, which is 1. And if I took negative 1, and this is actually a point that's worth making, I make it every year, and sometimes kids eventually get it. Suppose I took negative 1 and plugged it in there. You have to use parentheses. Quick sidebar, and I can't do this enough because kids still get it wrong. Negative 1 squared is positive 1. If I have this with no parentheses, that's negative 1, where you square it and then make it negative, okay? And anytime that you're substituting a number in for a variable, there should be parentheses, okay? So these are all going to be of this variety right here, where they're going to become positive once you square them. All right, so if I plug in, so I got the negative 1 squared is 1, 1 plus 1 is 2. If I plug in negative 2, that's going to be 4. 4 plus 1 is 5. Negative 3 turns out to be 10. You'll notice actually that this is got these two values are the same, these two values are the same, these two values are the same, because this is going to be a parabola, and a parabola is symmetrical, which means in a moment I'll show you that the 0, 1 is the vertex, and the rest of it, since they're equidistant from it, they match up perfectly. So let me graph the points and you'll see what I'm talking about. If I go over here to my graph, 310 I think is already off the graph, but I can go 2, 5. 1, 2, 3, 4. Yep. I can get 1, 2 is over here. 0, 1 is here. Negative 1, 2 is here, and negative 2, 5 is there. So you get this u. Okay, and that's called a parabola. And sometimes they'll open up, and other times they'll open down. Okay, this would be opening down variety. This would be the opening up because the mouth goes up. Okay. Yeah, okay, back to this. All right. So let me get to vertex form. There's a driving equation for vertex form, and it's this. We can have a f of x. Sometimes you might see y. Those are really rather interchangeable. A times x minus h to the second power plus k. You should know that equation. For a quiz, whatever the next assessment is. All right, so when I have this, that means that the vertex is going to be hk. The axis of symmetry is x equals h. If a is positive, it will open up, which of course looks like this. If a is negative, it opens down. Which will be the other direction. Okay. All right. There's also what's called standard form. I'm not doing as much with it in this section, but let me list it so you can at least identify it, which would be f of x equals ax squared plus bx plus c. Okay. So that's your standard form also. All right, so I'm going to jump in and start doing some problems, and it's going to be much more around the vertex form. So if I had this equation, y equals x minus 4 squared plus 0, I'm going to ask what is the vertex? Axis of symmetry. And is it a maximum or a minimum? All right, so let's see. Let's start with the vertex. So the vertex is hk, and if I put that equation right above this here, a times x minus h squared plus k, you can see pretty quickly that h is 4, and it's positive 4, because they're both subtractions there. That one's subtraction, and so is that one, which means if I plugged in positive 4 into this equation right here, I would get the same thing as I have here. Okay, so if it was opposite signs, then it would be negative 4. All right, so h is 4, and k is going to be that number. Sometimes it might not even be there, right, because you could always put plus 0 at the end. So that's k, which is 0. So my vertex is 4, 0. Okay, now maximum and minimum has to do with whether it opens up or down. Does it open up or down? In this case, A, there's nothing in front of the parentheses, which is where you'd find the A. So there's always an implied 1 there. I can put it right there. So A is 1, which is positive, which means that it's going to open up. Okay, just quickly over on the side here. It has to do with the vertex. Is it the top of the mountain or the bottom of the mountain? This would be a maximum because it's the highest point. Okay, this would be a minimum because it's the lowest point. Which means if A is positive and it opens up, this is therefore going to have a minimum. Okay, so I got minimum, I got the vertex. Oh, and the axis of symmetry is x equals h, which means x equals 4 is the axis of symmetry. Because I already found out that 4 was H, okay? All right, so that's the first one. Number 2. What is the graph of f of x equals 3 times x minus 4 squared minus 2? And I'm also looking at, is it a maximum or minimum? What is the axis of symmetry? What's the vertex? Domain and range. Is it a stretch or compression? And by what factor? I'm going to scroll back for 1 minute. I think I forgot to write one thing on this. It's right over here. Also, if A is greater than 1, it's a stretch. Less than 1, a compression. Ran out of space. I'm going to rewrite that. It's not just that it's less than 1, it's really between 0 and 1. No, I got put away. This should just be the absolute value of A. That's the easiest way to do it. Because it has nothing to do with whether it's positive or negative, and I don't want to be confused with the, -2, for example. Really, we're looking at +2. All right, so that's what I want you to finish writing in your notes there. Sorry about that. Let me come back to this. Okay. All right, so I can actually answer all of these without graphing it. However, I'm going to take a moment and graph it anyway. All right, so let me go over here to my favorite online free graphing calculator called Desmos, because sometimes it's helpful to just get a visual on this thing, especially when we start talking about domain and range. So when I plug this in, the f of x equals 3 times, so this doesn't have an f of x button, so I'm going to use y equals 3 times parentheses x minus 4 end of parentheses to the second power, and then minus 2. Okay, so that's what my graph looks like. So you can see clearly that, the vertex is going to be right down at 4, -2. And I certainly could have pulled it right out of that equation too. The number inside the parentheses is going to be the opposite sign of what you'd think. So it's -4 there, but that turns out to be +4. But the -2 outside, k, h and k, h is the 4, k is the 2. is exactly the number you think it would be, which is -2. So my vertex is that. Now, if I was to put in for a minute the axis of symmetry, which is x equals 4, let me show you what that looks like, because that's a line that cuts the parabola right down the middle. It's that blue line there. You can see it cuts it right down the middle, which is why it's called symmetry, because it's symmetrical on both sides. Okay, so but it has to have the x equals, because it is a vertical line. It's not just 4, it's x equals 4. Okay, so an important distinction to make there. All right, so let me go back to my problem here, and I'll come back to the graph if I need to. I think I will when I do the domain and range. All right, so if I'm doing this, we already said, gee, that graph opened up, so it's gonna be a minimum. And we said the vertex, we said was 4, -2. Axis of symmetry was x equals 4. We're flying right through that. Let's get to the, I'm gonna do the stretch or compression thing over there. Now I wrote it down. You got enough information here to do it. You know that a is 3, which means it's greater than 1. Therefore, it's going to be a stretch. And since a is 3, it's by a factor of 3. Okay, nothing complicated there. And I'll show you in a minute why that is. Let me go back to that graph for a minute, though, as I am looking at the. I'm going to knock the axis of symmetry out for a minute, just so I can look at this. Okay, now domain and range. Domain will be all the x values that this function covers. Believe it or not, this thing will cover every single x value eventually. I mean, it's going to take a really long time, but all x values on that will get covered. There's nothing, in other words, there's nothing I cannot plug in for x. If I'm looking at that equation, x minus 4 squared, no matter what number you pick, you can plug something in there and get a number for y, okay? That's one way to think of it. So my domain is of the x values, all possible x values, which is all of them. So we call that all real numbers, all right? And I'll come back and write that down in the problem in a minute. Range, however, is not just like that. The range, the bottom, the y values, there is no y values below -2. If I'm looking at it, you can see it's right here. Here's -2 on the graph. And that above it is fine. There's lots of values there. That's where the curve is. But below -2, there isn't. So the range will be y is greater than or equal to -2. Okay. So that's that thing. Let me go back over here. Whoops, I clicked the wrong thing. We'll come back to that in a few minutes here. All right. So my domain, we said, was all real numbers. And I'm going to use the abbreviation for numbers. The range is y is greater than or equal to -2. All right. Oh, and the stretch and compression. Let me go back to that for a minute. Now, the stretch or compression has to do with, what compared to y equals x minus 4. Let me put this in. If I had y equals x minus 4 squared, parentheses squared, say minus 2. So I got everything in that except for the 3. So you can see that it's a stretch because, it looks like I took the green parabola and pulled it up. That's the way I think of it. You stretched it, you pulled it up by a factor of 3. If it was a compression, maybe I'll go up here, and which would make it, if I plugged in 0.5, you can see it makes it wider. It's a compression, like you pushed it down, made it fatter, okay? And that's the idea with that. That's why it's a stretch or a compression, one of the two. And it has to do with, if it was compared to 1, if A was compared to 1. All right, so we got that. 3. I think it's time for a you try. So you can try this one and you can bring it to me in class. Number 3, I want you to graph this. F of x equals -2. -2 is going to make it a reflection. Anyway, we'll get back to that. Minus 1 squared plus 3. And what I want is you can put it on a piece of graph paper. If you have a graphing calculator, you can copy that onto your graphing calculator. I'm going to give you an x and a y. I want you to plot out some numbers. If you don't have a graphing calculator, you can pick numbers like 1, 2, 3, 0, -1, right? What I would also like you to list for me, I want the vertex. I want to know, is it a maximum or a minimum? I want the domain. I want the range. I want the axis of symmetry. I want to know the stretch or compression and factor. Okay, you can answer all those like I did in the last one. Bring me a nice graph, and we will go from there. All right, so that's it for 4-1. I'm going to close it out with a little bit of music. Have a great night.